The aromaticity of a compound can be explained based on Huckel's rule. You may be heard about this term Huckel's rule. See, you can say a compound is aromatic if it is cyclic and if it is planar and fully conjugated and moreover possess a simple condition called 4n plus 2 pi electron condition or rule. And I'll explain what is that 4n plus 2 pi electron. So these are the condition must be cyclic. How do you say a compound is cyclic? If all the carbon atoms is sp2 hybridized, and which you can very easily identify if there is a double bond. And if it is planar, that you can very easily understood and fully conjugated and possess. What do you mean by 4n plus 2 pi electron? Let me to explain that. See, in order to explain the 4n plus 2 pi electron rule, I will take benzene as an example. Benzene. You know the structure of benzene which contain alternate pi electrons. Now, how many pi electrons are delocalizing here? See, very easily you can say, very easily you can identify there are 6 pi electrons are undergoing delocalization. 6 pi electron. So if you put n equal to 1, then 4 into, instead of n, now you can give 1 plus 2, then you will get, that is 4n plus 2 rule. You can get 6. So what you can find is, see, in your benzene, 6 pi electrons are delocalizing. Okay, so if the value is n, then it obeys 4n plus 2 pi electron rule. And you can say the benzene is an aromatic because it is planar. It is planar and it is having conjugation and there is delocalization of pi electron. So benzene is a system which is aromatic in nature. Clear? Now similarly, I can give you another example. Another example is this molecule called naphthalene. Naphthalene is another example for pi electron system. And how many pi electrons are undergoing delocalization altogether? 5 pi bonds, so there are 10 pi electrons. So if you put n equal to 2, then definitely 4 into 2 plus 2, so plus 2 equal to 10. So 10 pi electrons are delocalizing. So you can say naphthalene is an example for an aromatic system. It is cyclic and there is full conjugation. You can see alternate double bonds are there. Okay, and all the conditions are obeying. Okay, so we can have many examples for what is so called aromatic systems. So here you have certain examples. Okay, actually you have certain other system also like anti-aromatic and non-aromatic also. Okay, and what do you mean by anti-aromatic? Let me to take an example to illustrate what is an anti-aromatic. See, sorry. If you've taken this compound, this is cyclobutadiene. Cyclobutadiene, it is cyclic, it is planar, and there is conjugation. How many pi electrons are conjugating? 4 pi electrons. Clear? So it obeys 4n pi electron condition. Not 4n plus 2, instead it undergoes 4n pi electron condition. Such a system is called anti-aromatic. And if the compound is non-planar, it is not having planarity, then for example, See, if you've taken this particular compound, cyclooctatetraene, this is this particular compound, this is actually this particular one is non-planar, so it is non-aromatic. So these are the various systems. Actually, you have to study only aromatic system, but you must understood there are, you must aware of the systems like anti-aromatic and non-aromatic also. Now there are more example for non-aromatic and anti-aromatic, aromatic, etc. Now, there are more example: naphthalene, phenanthrene, anthracene, etc. And what is the peculiarity of this one? These are polycyclic aromatic compound. Polycyclic aromatic. Now these are heterocyclic aromatic compound. What do you mean by heterocyclic? Other than carbon, you have a heteroatom in the ring. In pyridine, it is nitrogen. In pyrrole, it is again nitrogen. Furan, oxygen. Then thiophene, sulfur. See, if you take any of these, say for example, furan as an example. Furan is heterocyclic with the oxygen as the heteroatom. See, let me take furan. In furan, oxygen is a heteroatom. So here what happens is, these two non-bonding electrons also involves in delocalization. So including these two non-bonding or lone pair of electron, there are 6 electrons are delocalizing. 6 electrons are delocalizing. Clear? And these two electrons, since these two electrons also undergo delocalization, if you put n equal to 1, again it obeys the condition of 6 pi electron delocalization. That's why the compound furan is considered to be an aromatic compound. Clear? Similarly, if you take pyrrole, pyrrole also is aromatic due to the same reason. Now these, so this were we discussed earlier: furan, thiophene, pyrrole. Everywhere in pyrrole, the two non-bonding electron of nitrogen or lone pair of electron of nitrogen undergo delocalization. In sulfur also, I mean in thiophene also, the same thing will happen. Okay, and these are some non-benzenoid aromatic compound, which means these do not have benzene ring, but still they are aromatic in nature. So these are example for various kind of aromatic compounds. The first one is cyclopentadienyl anion. This compound is cyclopentadienyl anion, and where you have a pair of non-bonding electron, and this non-bonding pair of electron will undergo delocalization. And here also this cycloheptatetraene that also undergo delocalization. So that's all about the